This is the third portion and the final portion on custom graphics. In this particular portion, we're going to write a function that does something known as exploratory data analysis, sometimes abbreviated EDA. We're going to name this function EDA. So the first thing we want to do is we want to see if there is an object somewhere out there in R that is already named EDA, and if there is, we don't want to use it. So we will use the exists function to see if it is out there. So we check and see if there's anything named EDA, and there isn't, so we're going to go ahead and write a function named EDA. We're going to do this in the top window in case we need to modify it. So EDA will be a function which calls a single argument x, which will be a vector containing data values. And the first thing we want to do is make a call to par with the argument mfrow. And by the way, that stands for multiple frame row, which is to say we're going to have a bunch of plots all put together. And the arrangement that we're going to do is we're going to put those plots into a 2x2 matrix. Now, the fact that it's MF row and not MF column means that those plots are going to be put in row-wise. First thing we're going to do is we're going to produce a box plot of whatever is in the vector x. Next thing we're going to do is plot a histogram of what's in x. That'll give us a good feel for the shape of the distribution. Then we're going to call plot.ecdf, which you've seen earlier, to make a plot of the empirical cumulative distribution function. And finally, what we're going to do is call QQnorm to see if the data set is normally distributed. So there is our function named EDA, and it's probably not a bad idea right now to go ahead and run that code and see if it works. So far we didn't get any errors, so that's a good sign. So at this point we can call the code, and we could call it from either the top window or the bottom window. Let's go ahead and call it from the bottom window. Let's say we want to say EDA of the rivers data. These are lengths of rivers in North America. And I can do Control-All to highlight them all. I can also just highlight them with the mouse. And when I click Run, you can see what happens here. And this is a little bit flattened out, so let's raise it a bit. Here are the four plots that you have. The first one is a box plot of the data, and you can see it's highly non-symmetric. You have a whole bunch of outliers out here. These are lengths of rivers, and there are some very long rivers in North America, but most of them are on the shorter side. So there's the histogram in the upper right. Notice that they were put in by row. Then the third one is the empirical cumulative distribution function. And if you want to get rid of those dots that it is putting in there, you can use the verticals argument and the PCH argument if you'd like to in plot.ecdf. And here is the normal QQ plot. Now that does not look at all like a line, so apparently the normal distribution, that is the bell-shaped distribution, is not good for this rivers data, and that's exactly what you see up here in the histogram. So if you wanted to put in some of those corrections, you could come back to the plot.ecdf function. You could put in verticals equals true, and you could also say plotting character is the empty string. In addition, if you wanted that red line to be included on the QQnorm command, you could also put that in, and the way you put that in is with the QQline command. So you would say QQline of X and put in the color being red. And then what you can do is once again highlight all of this, push run, And now you'll see you get a nicer looking ECDF. You don't get those large dots. You also get a red line, which gives you further evidence that the normal distribution is not a good fit here, and you can see that by the histogram. So now that we know that this is not a good fit, let's try another one, which is our precipitation data set. And so once again, you can select all of those, push run. This time what you see is in the box plot for the precipitation data, it is fairly symmetric. The 25th and the 75th percentile are here. I'm sorry, those are the min and the max. We've got outliers on both ends. This is not perfectly bell-shaped, but it looks pretty close. And if you look at the empirical cumulative distribution function, it has a little bit of the S shape, so you're not going to get a real good normal fit here. But in any case, you can see in the middle of the distribution, it's looking pretty good on the QQ norm plot, just having some problems down here towards this end. And that corresponds to these cells that you see up here in the 0 to 30 range. Those are the ones that are not doing well in terms of the normal fit. Let's make one more call, and instead of putting in a real data set, let's put in a fake data set. So we could put in EDA of our norm of 200. This will generate 200 standard normal random variates, and when it does so, let's see what that looks like. So again, highlight them, click run. This time we also have a fairly good looking box plot in terms of its symmetry, so that's telling us something. This does look close to bell-shaped. Again, it should be bell-shaped because we generated random normals over here. The empirical cumulative distribution function does that kind of classic S-shaped to its profile here. And now when you look at the QQ norm call, you can see that red line does pretty well all the way out to a couple outliers here and there, and that's not bad. I like running this time and time and time again before I'm actually going to look at a real data set, and let's just do that time and time again here. And you will see each time you run it, you're going to be generating 200 normals, and some of them are going to look very normal, some a little slightly less so, like this one right here does not look so normal. That will happen even when they're generated from the normal distribution. So let me click a couple more times till I get one that looks like it's fairly good in terms of the bell shape. That's not bad right there. So when you look at that one's got a nice bell shape to it, and notice in the QQ plot, it does pretty well all the way up and down the line. And so before you actually analyze a data set of 200 values to see if they're normally distributed, you want to look at these exploratory data analysis plots to get an idea of whether that is a feasible model. This ends chapter 21, and next will be chapter 22. Remember that there's a lot more in the book than has been covered here, so please read chapter 21 and experiment a little bit with custom graphics.